example on solving oblique triangles. So in this case, the triangle is already provided to us. We have a triangle ABC. We have the measure of angle A. Then we have the lengths of A, side A, and we have the lengths of side B. But what is missing is three things. We want to figure out the value for C, the length C, which is also the length of the line segment AB. And then we want to also figure out the measure of angle B and measure of angle C. So guys, in this case, again, we are going to try and set up the sine law, and from there we can see how we can figure out the missing quantities. So let us start writing the sine law. In this case, again, I have used the side lengths over the sine ratio. So A over sine A equals to B over sine B. Guys, I'd like to start by rewriting the law, the sine law, and then I would substitute the values. C over sine of C. Guys, in this case, again, you can see the triangle was already provided to me. I took this example from the textbook. The triangle was already drawn for me, so it is already given to me. I'm just starting by writing the sine law. But in some examples, guys, if the triangle is not provided, you can go back to my example number 2 where the triangle was not already drawn for us. The information was provided, so one should first draw the triangle and then one should start using the sine law. Okay. So A over sine A is B over sine B equal to C over sine C. So in this case, let us fill in the information that is already provided to us. So A is 24 over sine of 36.5, and then I'm going to fill in the rest of it. B, I know the value for B. The length B is 34 divided by sine of B. I don't know the value for the angle B. And then guys, we don't know the length C, and we don't know the value for the measure of angle C. So this is the sine law for this particular triangle. Now from here we can clearly see that we should use the first and the second ratio to figure out the measure of angle B. Once we have it, then we can find a measure of angle C and then the length of side C. Okay, so we take 2 at a time. We should write the sine law with 3 ratios, then we work with 2 at a time. So from here, let us work with this one. 24 divided by sine of 36.5 equals to 34 over sine of B. And to find the B or measure of angle B, we have to first cross multiply. Guys, if we cross multiply, we get 24 sine of B. So I multiply 24 times sine of B and then 34 times this. 34 times I have sine of 36.5. So in order to find B, we have to first divide both sides by 24. So this will cross out, and also the right hand side. So guys, now we have this equation right here. To solve for B, first I would simplify this using a calculator. So using a calculator, I get sine of B equals to, so I have already simplified this, I get close to 0.8426. Guys, I only have rounded to 4 places. If you want to go further, you can, but I would suggest just going up to 4 places. Guys, from here, first thing we should make sure that is this less than 1 or between -1 and 1? Yes, this is less than 1. So that means we will have a valid angle because we know the range for sine function is between -1 and 1. So in order to find that value for angle B, obviously guys, we cannot find this on a unit circle, so we have to use the inverse key on our calculators. Once we use the inverse key, so which is like using sine inverse of, you have to type in 0.8426 in your calculator. And guys, we definitely need a calculator for this. So once you put it in a calculator, we get something close to 57.4 degrees. That is what we get for the measure of angle B. But here, guys, we have to be a little careful, and that is one of the reasons why I chose this example. Guys, so this is something that you have to focus on before you start moving on and finding the other values. Well, we got the value for B. Now we would be tempted to just directly find C, and then we could find the length of C. And we know how to do it. We're going to use this ratio. But before we do that, guys, let us remind some concepts that we have learned from solving trig equations using the unit circle and using some other basic concepts that we know about the trig functions. Guys, if you think about the sine function, we know sine has to be between -1 and 1. That is one of the basic things that we know about the sine function. The other thing we know about the sine function is when we think in terms of the 4 quadrants. We know sine is positive in the first quadrant and the second quadrant, and at the same time we know sine and cosine, they're all periodic functions, right? Both are periodic functions. They keep on occurring over and over again. So guys, here I have a sine of an angle positive, which is less than 1, so it is within the range, and we know this, it repeats at the same time, guys, sine is positive not only in the first quadrant, because here we got the value 57.4, which is obviously in the first quadrant. But at the same time, guys, we already know there's another value, which is basically reflection of that angle. You can think of reflection of that line, or if you think of a unit circle, where this is like the radius of that unit circle. So what I'm basically talking about is this thing, guys. If this is my angle, and this is that unit, we think about a unit circle, and where this is the radius, and this is angle 57.4, and for sine of B being 0.8426, then guys, we already know that there is one more angle right here in the second quadrant, right? Second quadrant. So the circle should be little, let me widen the circle. And there's one more angle in the second quadrant whose sine is also going to be 0.8426. That is something we already know, right? From our basic understanding of the fact that sine is positive in the first and the second quadrant, and it will repeat. So guys, how are we going to find this angle? So to find this angle, there's one thing we already know, that this angle and this angle are the same. So if this is 57.4, then this is also 57.4, but we're interested in this angle. But guys, we know this whole angle from here, we always measure from this as a reference side. This whole angle is 180 degrees. So to find this, just this angle, let me use a different color marker for that. So to find this angle, which I have tried to draw in green color, is going to be 180 degrees minus 57.4. So guys, in this case, this is again a special type where we are going to get two different angles for the value for, or two different values for B, and that would automatically mean we will have two different values for C as well. What does that mean? That means in this case we don't have only one possibility. We don't have only possibility that we can have one triangle, but in this case we are going to basically be able to create two triangles. Again, let us go back and make sense out of this. So what I'm trying to say here is, based on what we found right here from this equation, and then calculating B to be something which is in the first quadrant, so we could find kind of it is reflection in the second quadrant, because sine is positive in the first as well as in second. So based on that, what we can, if we go back, given this information, measure of angle A and value for B and A being 24 and 34 and 36.5, what basically we are trying to say here, or what we can say based on this information, is that there is a possibility for getting or creating two different triangles. So not just one triangle, but two triangles. Okay, so let us figure the rest of the values, and we'll have two triangles here. So guys, if B is 57.4, then the other value for B is going to be 180 minus 57.4, which is going to be 122.6. So there is two cases. So we got to break it down. We got to first do the case 1, and then we'll do the case 2. So for case 1, let us say the measure of angle B is 57.4. So guys, based on that, let us first find the measure of angle C, and then the length C, and then once we are done with that, so we have created one triangle. Then we are going to use this measure of angle B, measure of angle B, and measure of angle B. So I'm going to use this next for case 2, and we are going to get a different value for C. Okay, so for first one, case 1, when measure of angle B is this, then measure of angle C, we can easily figure this out, which is going to be, because the sum of all the three angles is 180, so it's 180 minus, we got to add the other two, guys. Other two is 36.5 plus 57.4. So when we simplify this, I already have the values for that. So I have measure of angle C. Measure of angle C is 86.1 degrees. That is going to be for case 1. I have measure of angle C. I have to now figure out the length of the side C. To do that, guys, what I have used here is, I have used these two equations, this one and this one, these two ratios. Guys, you are free to use the first ratio and the last ratio, it is up to you, but I have used the second and the third. In both cases, you are going to get the same answer. So I have used this 34 over sine of B. Well, I already have the value for B, which is 57.4. Actually, I should not be looking right here. I should be looking up here, because I have already started doing this case 1, and I have all the information right here. And then this is equal to the length C over the sine of C, which is sine of 86.1. Again, guys, to find C, you've got to cross multiply. And when I cross multiply, I get C times sine of 57.4 equals to 34 times sine of 86.1. To get C, we have to divide both sides by 57.4. So we've got to divide both sides by sine of 57.4. sine of 57.4. I'm not going to substitute the values for sine here or here using a calculator. No guys, we don't want to do that. We will do it all the way at the end. So we cross this out, and once we simplify this side using the calculator, this is what we have for major length of side C is 40 plus 26. So guys, we have in our first case, the first triangle that we're able to create with this information is a triangle which has these values for angle A. For B it is 57.4, for C is 86.1, and then we have the lengths for A, B, and C, 24, 34, and 40.26. Okay, and guys, this also makes sense because the biggest angle is 86.1, which is the angle C, and we know that the biggest angle will have a bigger side opposite to it, and 40.26 is the side that is opposite to that, and then opposite to 34 is angle 57.4, and then the smallest one is this angle, and that is the opposite to that is the smallest side. So it is kind of consistent with what we basically know about the lengths and the angles of the triangle. Okay, so guys, that is case 1. Let us talk about the case 2. Well, it's basically redoing the same thing. So let us make some room. Probably I can make some room right here. So for case 2, we are going to start by writing, so case 2. So guys, for case 2, measure of angle B is going to be 122.6 now. And then from there, we are going to first find the measure of angle C. And let us see if we can actually find that measure angle C. We have to use the same formula, 180 minus sum of the other two triangles, 36.5 plus 122.6 degrees. Guys, when we simplify this, again, I have already simplified that, we get something close to 21. That's what we get for measure of angle C. Okay, so once we have it, then we are going to apply the sine law to find the length of the side C. So let me first write that sine law. It's we have B over sine B equals to C over sine C. Because I got rid of it, so I just want to first write the general form, and now I'm going to replace the values. B, what is my length? B is 34. Sine B, sine of 122.6. Guys, be careful. This is not too complicated or difficult concept, but sometimes because there's so many things happening and then we have two different angles, sometimes I see students, although they find both the angles, but then they would just repeat or use the same angle over and over again. Like if they use 57 here, they would put 57 here. But guys, that is not going to give us the second triangle. That's probably going to give us the same triangle. So please make sure that once you have both the angles, you divide it into two cases. Case 1, you work with first angle, and then case 2, we work with the second one. So this is equal to C, length C over sine of 21. Again, we have to cross multiply. Once we cross multiply, guys, I'm going to skip that step. Finally, we get the side length for C after cross multiplying, which is basically, guys, just repeating the same type of a procedure. So finally, we're going to get C is equivalent to 14.45. So guys, you should actually calculate all these values using a calculator yourself. But guys, this is what we are going to get. So we have two triangles. In the first triangle, we have the A, B, and this length A is already whatever is given to us. And then we found the measure of angle B. This was our B, this was our C, this was the length C right here. And then for the other triangle, so for the other triangle, we found out a different value for measure of angle C. We have a different value for measure of angle B. And then obviously our length for C is also different. Okay. So guys, this is example 3. Again, this is like a special type where we are able to create two triangles. But one would again not know that unless and until we set up the sine law and we do all the math. Guys, this is a very critical and important step here to realize that when sine is a positive value and less than 1, then we know that it will occur not only in the first quadrant, it will also occur in the second quadrant. So you have to make sure that once you get the first angle, which is like a reference angle, then you have to find the other angle. How do you find it? You do 180 minus that angle, you find that other angle. Once you have both two angles, then you divide it into two cases. Okay, guys, example 3 is done. I'm going to show you more examples. I will cover all the different types using the sine law before we move on to the cosine law. Till then, guys, keep practicing. See you next time.